All right, let me see if I can get the audio here. Okay. You guys should be able to hear me. You guys able to hear me? I don't even think I could hear myself, but it looks like you guys can hear me out there. So I apologize for the late start, ladies and gentlemen. Let me go back to the browser. I was with the chair having a discussion. And so anyway, we do have a late start. Let me make sure some things are in order. Looks like we're good to go. Okay, so what I first want to do with people today, let's go over to, let's go over here to our website. We're going to go to worksheets and videos. And let's see here. Let's go over, and I'm going to put that there. Okay. So what you guys are looking at, good afternoon to a lot of you guys here. Good morning. Let's go to the iPad. So I did find the error from yesterday. So we want to clarify this. We want to actually do this again so you guys can see that. Now, what can happen is you can simply draw an incorrect picture. So let's go over this one again as we continue with some of these applications. You guys are going to see more problems in this application. We're going to complete this today. So let's try to see what we can do, okay? So let's kind of do this one again. And let's recall a few things, right? Here's the deal now. So as you leave the home port, you say, where's your home port? Your home port's right here. What's the deal? You travel north 70 degrees west. So you're going northwest. We're going to try this one again with the correct picture and see how this goes. And then hopefully this picture is correct, right? So you're leaving here for 40 miles. So that angle, maybe we'll change the color here, right? That angle measures 70 degrees. All right, so we say, okay, that angle measures 70 degrees now. And of course, you're going for 40 miles. So we're going 40 miles. All right, that was nice. We didn't use distance equals rate times time for that first part, right? And then what does a fisherman do, right? Went for 40 miles. It goes to the next day, traveling now, let's go green, 65 degrees northeast. So you say, what is 65? 65 degrees northeast is right in here, as we seen yesterday, and he's traveling for 60 miles. Okay, you guys okay with that? And then you say, okay, find the distance between what? Fisherman's, the home port and Forest Island. So again, from yesterday, they want this distance D. All right, you guys okay with that? Now, I'm just kind of curious. Is there any other information that they gave us? Can you guys see that there? Right, you guys see that there? Is there any other information that they gave us? Now, what did we do yesterday? Do you guys remember? What kind of triangle is this? Does anybody remember how from yesterday? I'm going to change this color. I think from yesterday, we were able to deduce the angle here. Is that true? What was the angle yesterday? And how did we get that? Double check your notes. What do you guys have in your notes? Anybody here? Let's get out our sound effects. We got about at least 10 people at home online, comfortable, maybe somebody at home. Okay. So let's see, ladies and gentlemen, what's the deal? How did you get that angle there from yesterday? Oh, okay. Well, let's see what we have from yesterday's notes there. See if you guys remember. I think I might have even erased it, right? You go, oh, that was 45 degrees from yesterday. It's a different picture. Right? So how do we know that this angle here, see if you guys remember, how do I know that this angle here is 70 degrees from yesterday? Right? How did we know that that's 70? Do you guys recall? What did you guys do yesterday? I think we used transversal. Is that right? Here's line 1. Here's line 2. They're parallel. And so we use transversal information. You're looking at a transversal, right? So that was what we did yesterday. So if that angle there was 70 degrees, looking at a transversal, the other angle there is 70 degrees. And then that gives us all the information we need. Is that right? Do you guys remember that? So let's get out the TI again. Let's open this up. And so this is a straight line. So from yesterday, we got that 45-degree angle. And that was good from yesterday because why? What is this? Side angle what? Side. And when you have side angle side, what do you guys use? Just like from yesterday. When you have side angle side now, we use what? Law of cosines. Is that true? So from yesterday, we know that d squared is going to be what? 40 squared plus what? 60 squared minus 2 times 40 times 60 times cosine of that 45 degrees. So why was it 45 degrees again? Because we have a straight line here, right? This whole thing is a straight line. So if you were saying, well, if you guys are saying, well, how did we get that, right? Well, how do we get it? How do we get it? Let's find out here. Let's go to the TI calculator. If you guys remember that. And how did we get that? That was 180 minus the 65 degrees minus the 70 degrees, okay? And then you get that 45. So I want to make sure you guys remember from yesterday that that's how we got the 45-degree angle. And that is why in law of cosines, you got 45 degrees there. All right, so you guys are good with that. Okay, now, ladies and gentlemen, what is D going to be here? D is the square root of all of this. And so what did we do again from yesterday, right? So if we go to the TI and you said, okay, so we're going to put the square root, right? You get what? 40 squared plus 60 squared minus 2 times 40 times that 60 times cosine of 45. And we got yesterday 42.5. So from yesterday's work, just like today, that distance for D is 42.5 miles. So let's be careful here again. Hopefully this is going to work out. But the point I want to make is this. That already looks a little bit odd to me, in case you guys didn't know. Because you go, you know, one of the tip-offs, you might say, what what's the tip off that something was wrong? The picture has to be right. So whoever designs it really needs to be more thorough with the picture. Has to be more exact. Okay, you guys understand? The picture has to make some sense. So already when I look at this picture, it doesn't make some sense at all. But let's hopefully everything is still going to work out. Okay, so it's all based on that picture. That's a big factor. You can't change the physical setting on that. So, all right, so that was 42.5, and that was the distance D that we got from yesterday. So hopefully this picture is going to be fine. And then now you might say, okay, they want to know what the bearing is. How do you get back to the home port, right? Because you were at Forest Island over here, and you got to get home. You got to navigate home. That's an extremely important thing to do. Be able to get back home. So you got to navigate. Yes. Yeah. Yes. It doesn't have to be 40 squared plus 60 squared. It could be 60 squared plus 40 squared. So the question is right in here, because the order in which you add doesn't matter. And the order in which you multiply doesn't matter. So that can be switched. Yes. Yes. So you could put 60 squared plus 40 squared because they're kind of like the legs in Pythagorean theorem. So that's really what's going on. The order in which you add or multiply does not matter. Yes, that's a good question. Okay. So yeah. So if you say, whoa, what's going on there? It's just the order in which you subtract does matter. The order in which you divide does matter. And that's the difference. But anyway, I'm just going to remark that, yeah, the picture looks a little weird to me. But okay, let's hopefully, this is all based on the picture. It's not the issue with the math. So what I'm going to do now is this. Let's focus on getting back home. This is where we left off. To get back home, this is the next question here, right? To get back home from Forest Island, we have to travel south, right? We got to go how? Notice what I'm saying. I'm going to put a little arrow there. We got to go south what? West. Southwest. Is that true? We got to go southwest to get home here. So you're going to put south, west. Let's go back. Yeah. South, theta, what? West. So here's my theta. And like we described yesterday, we create another transversal, right, from yesterday. So here's my first line. Here's my what? Second line. They're parallel. So if you said, okay, here's line 1, here's line 2. Remember, we need that diagonal line. And let's kind of draw a nice diagonal line. That's L. What you want to see is that this angle is theta. That's what we're looking for, okay? That is where we left off, finding the heading and bearing. In other words, we left off in question B here. Okay, so it's really, that's the answer. South, theta, west. And so from yesterday, I believe we called this H from yesterday, right? That location, that vertice, H for home port. And so I want you guys to really understand what's going on in this picture, because the picture is worth 1,000 words. Getting that angle theta is how we're going to get, well, we're looking for theta. But what is the relationship, right? So I want you guys to note for that part, if I say to you, this whole angle we're talking about called H for part 2, H, that angle, and if you say, could you put angle H? Okay. What is angle H? Isn't it the sum of adjacent angles? Right? Remember, we worked on that in the first week. The sum of adjacent angles, isn't that 70 degrees plus theta? So angle H is going to be that 70 degrees plus theta. Now, what that means is theta is angle H minus 70 degrees if we solve now for the angle theta here. Okay, so be very careful. The picture is really you can't really change the picture. You can kind of have an approximate picture, but the picture has to be somewhat close. If it's not, then you have an issue. So whoever creates the questions has to be very careful with the picture. You can't just randomly draw some of these pictures. Okay. Now you say, well, how do we get that angle H, right? Well, we have to use, because what we have now is a triangle now. So we have this particular triangle, and it kind of looks like this. If we say, let me try to draw a triangle. So I'm going to put 42.5, 40, and what? 60. This is side, side, side. Is that right? And angle H is what you're looking for here. This would be that little h if we labeled it that way. So double check. Are we okay with that picture? Do you guys see my point? So this is still law of cosines. You say, well, how does law of cosines work? Here's what you're going to do for law of cosines, right? Little h squared, that's going to be 60 squared. And again, the legs don't matter. 40 squared plus 42.5 squared minus 2 times that 40 times a 42.5 cosine angle H. This is the law of cosines. So when you do your algebra, you get 40 squared plus 42.5 squared minus 60 squared. And then cosine H will give you, by using your algebra, 40 squared plus 42.5 squared minus 60 squared, everything over 2 times 40 times 42.5. So your H, and that's angle H, now is going to be your what? Inverse cosine, and here you go. Oops. Copy. And so when we did this yesterday, what did we get? Do you guys remember? What angle did we get yesterday, right? Second inverse cosine, put your parentheses. 40 squared plus what? 42.5 squared minus 2. I'm sorry, not minus 2. Minus what? 60 squared. Close that, divided by another parentheses. 2 times 40 times what? 42.5, and close that twice. And we ended up with approximately 93 point what? 3 degrees. Okay? So that angle H is 93.3 degrees. This is the blue portion here. But H is the sum of 70 plus theta. So 90, what was that? 93 3.3, that goes right here. So here's the deal. 93.3 degrees. And so now, does that make sense about theta? Now theta makes a lot of sense. Is that right? I'll put theta up here. This is my point. Your theta makes sense. 93.3 minus 70 degrees. I don't need my calculator for that. I don't have all my coffee. So that's going to be what? 23 point what? 3 degrees. Now, we can keep it as a decimal, or we can do what? We can approximate that to a whole degree if you want. You know, but, and I'll do that. But your final answer now, ladies and gentlemen, we're going to remove that. That's our theta. That's 93 degrees. I'm sorry, 23 degrees there. So 93 minus 70. And was it southwest? Yes. There you guys go. So this is how you get back home. Yes, it would be really in a decimal system to be more accurate. But the point is, we're going to keep that as a whole number. We'll approximate it at the end. And that's what I want to share with you guys here. The picture is important. So yesterday, our picture was off because we had the city home port was actually to the right of, Forest Island, and it's really to the left. And even the picture still is not as good as it should be. Okay? Still is not as good as it should be. So, ladies and gentlemen, but as you guys know, the process is important, and that's your angle, and that's how you get back home. Okay? So I wanted to make sure that we go over and find the mistake from yesterday. We found it. I found it. I looked at that and go, okay, what's going on? The picture was wrong. It's not as, if you look at the distances, yeah, it looks distorted. It's a distorted distance picture. So it's still distorted, but okay. So that's going to be a 23.3 degrees. So it's not as beautiful as it should be. So that's your typical navigation question, ladies and gentlemen. How to get back